Well, hello everyone. Welcome back. And today I will step aside from my binary reverse engineering into kind of like a little bit of obscure subject. And namely, I will be discussing serialization, and technically two parts, serialization and deserialization. But in this part, we will cover just serialization itself. If you follow the news, and especially security news, you probably know that serialization and binary serialization and deserialization have been the causes of many vulnerabilities. And yeah, so this is kind of like subject that is really exploited by, well, let's say, bad guys, but also I've been noticing that a lot of people on GitHub and especially on YouTube, when they show tutorials, they kind of, glance over the serialization part, something that is kind of like, annoying. Nobody wants to do it. And they literally just say like, hey, and this is very simple. I'm going to throw it in here and kind of like do it quickly. And they don't really pay attention to the security aspect of the process. So today I will code serialization and deserialization from scratch in C++, but this doesn't necessarily apply to C++ only. It can also apply to C# and other languages. But primarily I will cover the native world or compiled serialization. And yeah, so let's kind of do this. And again, we'll do it in two parts because this will probably be a long coding tutorial. And my main goal here is to show security practices, kind of like a secure practices when you are doing serialization. Now, what is serialization? I kind of like threw in this real quick diagram. Now, if you picture your app like this thing in the middle, this is your binary app or any kind of app, but in my case, it will be binary app, and it stores some data in memory, right? So all the stuff here is basically that data in memory that you kind of like work with, you operate, and you generally assume that the data in memory is secure, right? But then for some reason, well, not just for some reason, but you might be needing to save that data to file, like this kind of like arrow here. And then, like many programs, anything from binary programs to, from graphical programs to text programs, they create binary file, right, that they store, let's say, on the disk or anywhere else. And then they have to read that file back to actually get something, back into the app. So this process is the process of serialization. Basically, this arrow here of converting the data inside your app, mostly binary data or whatever format you're using internally, into something that can be represented in a binary form. Now, additionally, this can be anything that can be transmitted through the web, right? Quite popular format would be JSON, kind of like in a text form, but the principle is very similar. You basically take internal data that you work with in memory, that you trust, and then you convert or serialize it into some external format, in this case JSON or just a binary file. It can be pretty much anything. You're the author, so you can do anything. And then what is important, converting it one way is obviously not going to cut it. You also need to convert it back or convert it from that same JSON or from the binary format on file or anywhere else back into the app. So, and we will literally focus on these two aspects of the process, something that is, again, quite often glossed over. And why is it important, and why was it exploited so many times, and why would that cause vulnerability in software? Well, to be honest with you, the serialization part is not is not an attack vector for bad guys, although I'm sure it can be exploited as well. What is mostly attacked is deserialization, even though we say serialization, but in reality it's deserialization. Or in other words, when we take external format and we try to convert it into internal format. And this interface right here, right, between the two is what really makes it vulnerable, especially if there's not enough security checks that the programmer makes. That is why this part is very, very important, and we will cover it in the next tutorial, so please check part 2. But today, to actually, be able to work with something, I'll cover serialization. In other words, conversion of the binary format from the app's memory into some external format. In this case, I will be using my own binary format, and that's what we'll do today. Now, before going into inventing your own serialization process, I would highly recommend, if you are using some well-known, proven library, to actually use serialization techniques in it. This is very important because, serialization is kind of like encryption. Also, I would say probably not as difficult as encryption, but still the same principle applies, especially for the beginners. You do not invent your own serialization, especially if you don't understand it well. So if there is a library that comes with the built-in method to serialize your data, make sure to use it. Most certainly people that wrote that serialization principle know it really well, and you probably will not do it better than them. Now, in this tutorial, we will be discussing serialization process for those people that are writing it for those aforementioned libraries. So in other words, how you can do it right and how you can do it as secure as possible. Okay? Well, guys, so this is the diagram, and let's begin. Again, in this part, we will cover serialization. If you are concerned about deserialization, check part 2. And so let's begin. As you know, I usually create a new kind of test project in Visual Studio. I'm using 2022, but pretty much any version will work. I try to go with the C++ template, and in this case I'll use console app because I don't need any graphics. And I would call BinSerialize. Again, just it doesn't really matter. It's just a small project. I'll post it on GitHub, by the way. All the links will be there. So if you want to see the final product, if you don't want to watch me type all the stuff, but if you do, let's begin. Okay, so we will start from, well, just kind of like formatting our project a little bit. Let me make it a little bit larger so that you can actually follow. And I'm going to expand, and let's see. Okay, so we don't need any of this stuff, so we just need basic template. And to make it a little bit more readable, I will break it up into several files. So let's add an H file, and just for this example, we will need to create some kind of fictitious data. So in this case, I will create, well, let's just say like fictional class meaning the class in school, and then we'll add students into it just to give us some, bones basically to work with. So I'll call it MyClass. And inside of MyClass, I will create a class, and I will name it struct because, there's not much difference between structures and classes in C. And for my case, I like that struct kind of creates, all the members start as public by default. Okay, so my class will create some members inside that we will serialize. And we will probably need to create another header file, and I will put types, and I will kind of try to show how I will code a production style, production grade code so that you can actually see all that stuff, because it always amazes me when you watch tutorials and people gloss over like logging or providing, comments or good variable names or error checks, and they're like, yeah, make sure to do this in the production code. But all the people that watch this stuff, they don't, they don't see it. You have to show it. So anyway, I will try to make it as production ready as possible. So that is why probably it will involve a little bit more typing than usual. So again, if you want to skip forward, go ahead and you can do that. But anyway, so what I usually do, I put brief comments. Let's say custom declarations, and here will be fictional class to demo serialization and de-serialization. Unfortunately, not the easiest words to type. Okay, and okay, so I think we can start here. Okay, well, just to show different types of objects that you can serialize and work with, I will just create again a fictitious class. And for instance, we can say the first parameter would be year established. And I will always initialize class. Again, we'll be using one of the newer versions of C++. So instead of doing it in a constructor, I will do it right here. Now, guys, I don't really care how you do your formatting. So if you do like your curly braces this way, if you use tabs or spaces, or how you name your variables. Now, I think this is kind of like superfluous. It's not really important as long as the code is readable. In my case, I like to prepend my variable names with kind of like my own types. So if you don't like it, don't do it. Again, this is not important for you to do it. What is important, though, is to leave descriptive comments of variables. In my case, I would say like year the class was established, and 0 if unknown. This is important to document all the variables, even though sometimes they might be kind of like obvious in this case, but you need to show what exactly, you know, the variable means. Now I'm realizing that I will be short on the horizontal space, so what I will be doing, I will be putting comments above. And what is also important is to show limits of this variable. Now, obviously, variables have certain ranges, and like for instance, the year established. Well, good example, it can be a negative number, right? Or it can be a number that measured in billions. So that is why it is very important to establish what is the frame, right? How, you know, what is the minimum range or the maximum range that this year is valid. Now for the years, let's just do, well, kind of like conservatively from 1000 to 2100, because I'm sure no one will care about this script past this year. And this is the range, acceptable range. This is important because, again, when we serialize and especially de-serialize, we need to make sure that our variables are within range. And what I prefer doing, instead of hard coding all these values, because again in the future things might change, I usually create a custom type, or in a custom type file. I create a couple preprocessor variables for C++, and in this case I might call it min allowed year, if you remember. So that will be this. And then I will say that this is inclusive, meaning that this year is allowed, but 999 is not. And another one, I would do the same, but with the maximum allowed year. And the reason I like to place these things into separate file and into separate, not file, into separate variables, is so that if you want to change it later, you don't have to hunt, you know, for these specific variables all over your source file and refactor it, and instead you can just go here and change it in one spot. So that's the reason. Okay, so year established. So, well, let's think, what else can we have for a class? Well, we can have a name. Now, before we do this, we need to include a string library. Okay, so in this case, I will be using ASCII strings to make it a little bit more cross-platform. I know that in Windows, the recommended way is to use white strings. But again, today I will try to write a little bit of a cross-platform code. even though I'm on Microsoft, but still, you know, I'll make sure that it can compile cross-platform. Okay, so let's call it name. And in this case, again, I'm using my own nomenclature to prepend names with kind of like the type. But again, it's up to you guys if you do it differently. Okay, so let's say name of the class, and it must be provided. Again, I'm just kind of like winging it. I'm just saying that the condition is that this name has to be provided. And let's say it has to have a maximum length. So again, let's create a global preprocessor variable, and let's call it max name len. And in this case, again, I'm just kind of like going with just arbitrary numbers. And let's say maximum length in characters inclusive. So in other words, this is the maximum length that is allowed, so 256 characters. And let's go back, and so what I'm specifying here in the comment are parameters for this name. It has to be provided, and max name length, well, I called it 2. Well, let's just stick with the name. It's 256 characters. And we'll use 1 for something else. And again, this is just a kind of like fictional example. Obviously, you know, probably won't work in real life. And let's say it will contain, I need to add one more library, and this is for the list or vector, and it will contain a vector of objects that we will add, which we'll call student, and they will be students. Like obviously class must have some students, and we will create them separately as separate object. But for now, let's say people associated with the class. Now there is no limits here. It can be 0 people, obviously, if it's a brand new class, or if it can be, you know, 10 million. Okay, so, and last one, just for the heck of it, let's just say, let's add nodes. And nodes will be, let's say, internal nodes about the class, and they won't have any limits, so it can be empty, or it can be pretty much any arbitrary size. Okay, and we also need to create a new class for our students. In this case, let's create another header file. Now guys, I will not be adding CPP files, because again, this is just a very simple example, so I'll put all the stuff into the header file. But in real CPP, obviously, in real class, you would use CPP files. Okay, so let's put class that describes students for a fictional class. Okay, and again, we'll create a struct, and no, that's not the name. Just move this thing over here. Okay, so the name is student. Okay, so over here we need to add our student. So local header file. And so now, yep. Okay, so this will be very simple class for my class, and now we need to create similar thing for the students. And let's just wing it the same way. So age will be 0. Oh, and by the way, guys, I'm not initializing all these objects, because they have its own internal constructors that will initialize it. And the only things I do here, I initialize primitive types like int and such, which do not have constructors. So that's why I put 0 here. Okay, so age, and we kind of do similar thing. Let's put a let's say age of the person, or 0 if not known. Obviously, in the beginning, we don't know the age of the person before we initialize it, so we set it to 0. And in this case, we also need to set the range. Now, in this case, we won't be using this crazy, range as we did here. Instead, we create new variables, and we will call them min allowed. Well, let's say age, right? And well, let's think about it. So what will be the minimum age of the person? Well, let's just say 10 years, right? Again, it's not really important, but kind of like to give some perspective here. And max allowed age. Now let's just be very conservative and say that someone can live up to 200. So in this case, the minimum age is this, and the maximum age is this. Again, by coding it separately in preprocessor variables or in constants, we can easily change them in one spot instead of refactoring the whole source code, especially when we work with larger projects. Okay, well, so what else does the student need? Well, obviously needs a name. Now, I will not go with like US-centric approach here, where everyone has first, middle, and a last name. Internationally, this is not the case, so I will stick with the given name, which I would say most people have, and then I would create second name and third name, and those will be optional. Now, before we go there, we need to move this thing. Actually, you know what, we can just copy it here so that we have, don't need this, so we can have access to the string. Okay, so let's call this one is given name, and let's say student's given name must be provided. And in the same vein as we did here, let's just say that the name of the student is max length 1. Because again, the name of the student has to be limited. It can't be, indefinite. And in this case, let's do max length 1. And just to be very conservative, let's give it 1056 characters in case, someone has very long name. Again, all these things are arbitrary. Obviously, it's a fictitious class. Okay, so let's see, and then we have 2 more. The second name and third name. Now, in this case, the correct way, if you are programming any kind of database, especially if it goes internationally, I would probably add fourth and fifth name, because sometimes people have very complicated names, and I would definitely make these optional and also limit the length to the same. The reason being is that some people, some cultures might have only first name, which they would call given name, and second name and third name would not be available. But some cultures, like let's say Spanish, they might have double what Americans call last name. So anyway, it's a totally different subject. In this case, 3 names would be enough. And just to make it more interesting, I'm going to create an enumerator and a num. Let's just say attendance type, and we will call it unsigned int. Now, this will be an enumerator for the student. The one that should be kind of like set by default is unknown if we don't know, what's the attendance type. Now, there is one when the student is enrolled, and let's just say student is currently enrolled. This is important to put a little bit of a comment here, even though sometimes it can be obvious, but sometimes it might not be. It's always beneficial for the next developer. Enrolling. Let's say if the student is trying to enroll, if they're in the process, well, let's create a good outcome if the student has graduated. Okay, well, the bad outcome if the student was expelled. Oops, was expelled. Okay, another bad outcome if the student dropped out. Let's say voluntarily dropped out, right? And let's say if the person is some external non-student, let's say person is not currently associated with the college, right? Again, I'm just kind of creating all these kind of like possible variations. And what we need here, we need to actually add attendance here, and this is the attendance of the student, right? So initially it will be unknown, and again, I'm setting it up because it's my own type. It doesn't have a constructor like all of these. That's why I'm initializing it here, which is very important to do because you don't want to have a dangling variable here with some some garbage in it. Okay, and this is type of the person's attendance, and we don't really need to specify the range because it's kind of like obvious here. These are like all available parameters for it. Okay, well, let's see, what else can we do? Well, we can say if the person is suspended, and true if the student is currently suspended, so that we can see how we can work with the Boolean variable. And again, I initialize it to false because it's a primitive type. And let's do like a floating point, and let's say performance score, and by default it's 0. And let's see students performance score. Now performance score can be any value, 0 obviously being default. And last thing, we probably need notes. I also need to spell it correctly. Okay, the same thing. Internal notes about the student, and it can be an arbitrary length. Okay, so at this point we have kind of like basic structure. Again, this is a single student, and then the student will be included in a class as a list or vector in the jargon of C++, or I'm sorry, of STL. So at this point, we have kind of like basic scaffolding. Now, before we can do anything, we probably need to adjust the constructor for the student so that we can actually fill it out. So let me do this real quick. So student, so that we can populate the array that we can work with. So we need attendance type, and let me do it like so you can see better. Okay, so we need attendance, then we need primitive type for given name, and this one has to be provided. Primitive type for second name, and this one can be omitted. And the same thing for the third name, and it can be omitted. Okay, and then we need to initialize our variable here. So age is age. Okay, over here we need to be careful, by the way, how we convert this C pointer into a string, into a C string or STL string. We have to check to make sure that it's not 0. And we have to do the same with the second name and third name. Always make sure to check when you do copy and paste that you actually change everything. Okay, and oh, and I forgot the attendance, so let's do that. Where's our attendance? So this is just basic constructor, so we can create some data to work with. Okay, and yeah, so at this point we can probably initialize some basic structure. And over here, let's just say create some data to work with. So we need to add our MyClass. And let's see, so yeah, in real life you obviously wouldn't be doing this kind of thing, but in here let's just hard code it. So we have MyClass, and just say MyClass established this year. MyClass, let's say name, oops. Class of 2023. And again, guys, if you don't want to watch me populate all this stuff, just fast forward. I'll put time codes in the description. Okay, my super fictional class. And okay, so now we need to actually add students, and let's do MyClass students, and we do push. And let's say student, and just create a few fictional students. Let's say 21-year-old, attendance type enrolled, and name is John Doe. And let's just create a few of these, kind of like just something, I don't know, let's say attendance 19-year-old and currently enrolling. Let's say Mary, I don't know, Smith. Like, how many names do we know? Let's see. Well, let's just say someone really old, which has graduated, and the person has 3 names. Let's say Kareem, Abdul Jabbar. Okay, I really don't know the age of Kareem Abdul-Jabbar. Just looked it up on Wikipedia. He's 76 years old. And okay, so he obviously graduated, and let's just add someone with 1 name, and the one that came to mind is Rihanna. Let's just say Rihanna, and her attendance type is not expelled, external. And I looked it up, and she is 35 as of today. And let's just create someone that is that's been expelled. Let's say some really old, well, not expelled, let's just say dropped out. And the name would be Unruly Kid. That's his name. So anyway, he dropped out. And let's add a little bit of data for these people. So for instance, for our John Doe, let's go back to him, and let's say his performance score is, I don't know, 12.5. And let's say the notes that he is the best student. Again, guys, I'm just winging here. So for Mary Smith, let's say that her performance score during the exam is 13.75. And let's just say in the notes that she will be attending in September, right? So then for Karim Abdul-Jabbar, we're gonna say that his performance score was like through the roof. And for Rihanna, we'll make a note. This is a celebrity endorsement, right? So again, just to give us something to work with. And for Unruly Kid, his performance score was -5.0. Great kid. And the notes, we should never enroll him again, an exclamation mark. And back then we suspended him, right? So this kind of like will give us some data to work with. Now let's make sure that this thing compiles. And when we put a breakpoint here and run, let's make sure that we get the actual data. And let me remove all this stuff. Okay, we don't really need this. So let's see my class. So it has 5 students. I'm sorry, is it my class? Okay, yep, 5 students, and we have John Doe, Mary Smith, Kareem Abdul-Jabbar, Rihanna, and Unruly Kid. And they all have to have, okay, Unruly Kid, -5 score, suspended, dropped out. And okay, so it seems like we have our data. And at this point, we are ready to serialize. So if you're joining us from the beginning by skipping forward, we have all this data. And right now we can go into our class and start writing our serialization routine. So, well, first, again, what are we doing? So what is the thing? Well, if you look at the picture, we are converting our internal data. And in this case, it's like all of this stuff, right, inside of a class that we have filled out internally. And we are serializing it into some arbitrary data structure, right? So this is what we're doing here. Okay, so I personally prefer to make a function, like an internal function for the class, something that we can call later and kind of like which will be a part of the class itself. And in this case, let's start from the student, because again, what we're seeing here is that the student is the internal structure. So let's kind of start from it. And let's skip all the way down here. And I'm going to put a little bit of a break here so it's easier for you guys to read. And okay, so my proposal is to write kind of like a 2-pass function. In other words, on the input, or not on the input, the first time that the caller calls it, the function will return the number of bytes that are needed to synchronize. In other words, what is the size of this, of the resulting byte array? So it's the first pass. And then on the second pass, the user will provide us an empty memory buffer, and the function will fill all the data in it. Okay, so well, let's try to code it. So on the output, the function will return the number of bytes, and I will call it toByteArray. It's kind of like descriptive for me. I just say, hey, this function, internal function, or member function, will convert our student object into a byte array. So that's how I usually call it. Again, it's not really important, whatever you want to call it. Okay, so on the input, it will accept a buffer, which can be a null pointer, and also it will accept the size, which can also be a buffer, and this is a const function because it will not be changing any of our internal parameters. And before we go, we need to explain in a comment what the function does. This is the most common mistake that I see a lot of developers make, and that is when they when they forget to comment or explain what the function is doing. They think like, hey, it's so easy, you know, why don't you see it? Obviously, you don't have to write a big essay on the subject, but just write the basic stuff would be very helpful. And we want to say that this is serializes this struct by converting it to a byte array, right? So on the input, if not 0, this is a pointer to the buffer to fill out, right? If it's 0, it won't obviously fill out anything. And this is the size of provided. So when the user calls this function, he or she needs to provide the size in bytes. Okay, and on the output, it's size of the filled or needed to fill buffer in bytes, or 0 if error. There will be errors, so if we return 0, the function basically failed. And again, I hope it's kind of like descriptive. So the first parameter, if the user doesn't need to fill out anything and just wants to know what is the size of the buffer that needs to be, they provide 0. Now, if they provide a buffer over here, this parameter provides the size of the buffer in bytes, and it can be larger than the needed size, so you know it's quite acceptable. And on the output, the function will return the size of the needed buffer, or how much it filled internally, and it will return 0 if nothing happened. Okay, so let's write it. Now guys, in this case I will write everything in the H file because again this is a small function, but in normal conditions you would actually write this in CPP, but just to make it simpler I'll write it all in one spot. Okay, so let's say originally this is return, and we return it. Sorry, not like this, but like this. And first thing first, we need to determine the size needed, and let's call it size data, and we'll see it here. So at this point we need to see inside the function how much data, what's the size of the byte array we need to store all of this stuff here, right? Now, there is a little bit of a conundrum here. Many people would just do something as simple as this, size of plus, right, plus the size of the next one, blah, blah, blah. Well, the problem with size of and with placing elements close in memory is that some CPUs might require alignment on a certain boundary. Now let me explain real quick. Just do it right here. So for instance, if we start placing, let's say, let's just say age, I'm going to number these bytes like so. I'm using like hexadecimal numbers. So if we do age, as you can see is int, so age would take this, 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 and this bytes, right? So this would be our age, right? So these 4 bytes. Well, in case of Intel or AMD CPUs, they don't care. So let's say if we put the next element here, right? So whatever the next element is, right? The CPU doesn't require certain alignment. But if you are dealing, let's say, with the ARM CPUs, and especially ARM64 CPU, the ones that kind of like the newer ones, they might require alignment on a certain byte boundary. For instance, they would want the next element to start on the address that is aligned by 8 bytes. And this might become important when you try to serialize. Now, the way we serialize things, we literally take these parameters and they put them, consequently in, or sequentially in memory. Now, obviously, the easiest way, right, or the one that where you conserve the most memory would be to put them like this, right, to put them sequentially without any gaps. But as I said, some CPUs do not allow it, and that might create a problem. So why don't we create a facility in our class that would allow us to align every element on a certain boundary. Okay, so for that we need to write a little bit of code here. Again, I'm going to our types file, and let's just create another preprocessor definition that would say align by. And over here we will specify the size of the alignment. So align by this size. And most CPUs would be aligning by the size of the pointer, whatever that value is, right? Let's say if you're on 64-bit CPU, this will be 8 bytes. On 64-bit, that will be 4 bytes, and so forth. But the main point for us is that we can align by this number of bytes, and I will aim at going for like arbitrary alignment, and also let's say or comment out to remove alignment. So if you don't want to align by anything, you just comment this thing out and alignment will be skipped. So this is kind of like we will try to write a universal class here. Okay, and also what we'll need to do, we actually need to write some code to do the alignment for us. And since we will be using this thing pretty much a lot, I would suggest coding it all in a template. Now you can technically do it in a preprocessor definition, but this is not ideal. Now, a preferred way to do it in a temporary C++ is to use a template. So let me show you how you can do this. So we'll just call some kind of template, and we'll do an inline one, because again, to kind of like try to basically make it more as efficient as possible. And let's just call it aligned, and we'll pass in a parameter again. So instead of doing, let's see, where is it? Instead of doing this kind of thing, we will write a small template that will give us the size, which is aligned. And what we can do, we can just say template that returns an aligned size for n, and n is size to align, and we don't really need this, and we returned aligned size. Okay, so very, very simple definition here, but first we need to see if our variable is, preprocessor variable is declared, and over here if it's not, there's no alignment, so we just return n. It's kind of like the easiest implementation. And over here we are using alignment that is declared on the global scale by this variable. And the easiest way to look at it, again, if we look at our example, right, so anything that is the size of the is the size of the alignment, right? So if we have 8 bytes, we don't have to pad it with anything, but anything less, we have to pad. So in other words, if the, let's say, the length is 3, well, it's not a good example, but let's say the length is 2, we have to pad it with 6 bytes at the end to make it, alignable by 8. And the very easy way to kind of calculate this, and we just say that we return n plus, and we calculate, how exactly we want to, how much exactly do we need to pad. And in this case, we need to see if it's divisible, not by size of, but by our alignment. So if that, right, so if that is not 0, we actually pad, otherwise we don't pad with anything. And in this case, the padding would be aligned by minus whatever the remainder of that division, right? So it's kind of like, again, I'm using parentheses to kind of make it as readable as possible. So in other words, I'm checking, okay, is the n, the value n, is it divisible by our aligned by, which in this case, let's assume it's 8. So if it's 8, right, if it's 0, we don't pad with anything, we just return n. And if this value is actually not 0, so what we do, we take aligned by and subtract this value from it. So it's exactly what we did here. Let's say if the value is, if the n is 2, 8 minus 2 would be 6, and 6 is how many bytes we need to pad it with. So, and this will be our template. So, and we can use it in our class like so. Right, so let's make sure this thing compiles. And let's see, why is it not liking our aligned? Oh, and that's because we didn't add our types. Okay, so let's see if this works. Okay, so now we can use our template here instead of specifying size of, and that template will depend on our aligned by. So for instance, if we remove it, so this way we will literally keep losing it. We will literally use size of age, like if there is no alignment. But then if we uncomment it, in this case, this will align to the 8 bytes in this case, but we can also adjust our alignment, but can just do like, I don't know, any arbitrary number, right? Okay, so let's continue writing. And again, guys, I'm going to remove this part because I think you kind of got it. So, okay, at this point, we have our size of variable, right? I'm sorry, we need to calculate the size of the needed data. Now it's easy with age, because age is just an int, but then we have a string. So how do we deal with the string? Obviously, string has a little bit more data that we need to save. And let's kind of think about how exactly can we save a string. So a string, let me just do it right here again. As a comment. So a string has 2 variables. One is the length, and 2 is just the text itself, right, or the string itself. Now, std string, this one here, consists of basically an array or vector of chars, and it has the length. So this is what we need to save. And when we serialize something, the important thing to remember is that we have to provide minimum information, but not provide too much information. Now, what do I mean by that? Well, you have to, if you provide superfluous information, for instance, if you provide length and then you start providing string, which is also null terminated, this creates kind of like 2 things that are encoded in, one thing that is encoded in 2 parameters. One is the length, which kind of tells you how many chars are in string, right? So technically you don't need null terminator at the end. But then if you have a null terminator, that kind of tells you how long the string is. So you have to decide which one is better. So you either provide null terminator and don't do this, or you use length and don't provide the null terminator. Now, personally, I prefer to use length because this is way more easy to calculate. It kind of like loses a little bit in length because you have to encode 8 bytes in this case, but you can also shorten it if you want to deal. Obviously a string would not be that long, so you can kind of abbreviate it to like 4 bytes, and you can use, I don't know, uint 32t instead. Now that creates added complexity. In this case, I will not be concerned with the size of my binary serialized data. In other words, with the size of this thing. I will go for security and simplicity, but again, you can internally convert, but then you will have to check this length. So in my case, I will encode it by using first the length of the string, and then by having a sequence of characters that follow the string. But we need to calculate the length of this thing. In other words, how many characters would this take? And we can kind of do it here. At first, we are using our formula, and we do align, sorry, not line, but aligned. And this is size t. Again, that's what we're adding for the string. And then we need to calculate the size of the string itself. And in this case, we will always be using our align template to make sure that every parameter is aligned on a byte, on a specific CPU alignment boundary. And in this case, we need our actual variable. We need to get its size. And then we need to multiply it by the size of single character. Now, in this case, the character is char, and many people will start laughing, saying like, well, the size of char is 1, so what's the point of doing this? Well, the point of doing this is that the std string is not always measured in chars. For instance, in Windows, quite often, the string will be presented as wide string. And in this case, you would have to do this kind of logic because, single character in that string will not be 1 byte. So to make things simple, I will declare a global variable on a global scale. And again, I'm going to use the preprocessor definition for that. And I will call it strchar. And this will be type of characters in the STL strings, right? So in case I decide to use wide string, right? In that case, I will put wchar here, but for now, we'll stick with this, with char, but what I will change it to is this. So as you can see, over here, we can clearly change the type of strings that we're using in one spot. This is very important to do it from the get-go because, the code is obviously way more readable, and also you can adjust it by changing it just in one spot. So now on, again, I'm suggesting using this kind of construct. And yeah, so this here will give us the size of a string. And guys, because we will have quite a lot of strings, let me move it into its own template. And I will kind of borrow from this one. And let me just call it aligned size of string. Let me write a comment. So let's just say calculates size of taking alignment into account. So, and the only thing we need to do is pass our string by reference. and it will return size t. So again, we're changing it a little bit because we're dealing with strings only. So t is stl string, and n, let's just rename it into s to be more descriptive, and we don't really need that. Just copy it from here. This is just a line size, right? So okay, and then we can do return and then copy it from over here because that's what we did before. Okay, so let's kind of look at it. So first, aligned is the size of the size t, which will give us the size, and over here we have our s, which is string size, and multiplied by size of our character. Okay, and then we return size t. So now we should be able to use our macro here and simply pipe in the name of the variable into it. And before we do that, let's move this thing into our template so that it kind of explains the breakdown of these parameters. And okay, at this point, let's see if it compiles. And we evidently made an error somewhere. Oh, obviously we need semicolon. Okay, so at this point, we can just use this simple template to kind of like help us coding it. And again, guys, you can hypothetically code it like, you know, raw without using any of the templates. For me, I kind of prefer doing it this way because it's, well, it's kind of like easy to make mistake if you know, code something, especially doing copy and paste, and kind of like make a few mistakes. Okay, so let's just do quickly and populate this. So we have second name, then if I remember we had third name, right? So pretty much the same template. Let's see, what else do we have? Okay, we have attendance, and for attendance we will use our first macro, size of attendance, right? So this is kind of the same. I think we can just repeat it for the rest of them. Just have to remove. Okay, so we have attendance, we have suspended, performance score, and last one is notes, and notes is one of these guys because it's a string. So the important thing when you copy and paste, make sure that you completely change everything. And over here, this construct will give us the size that is required for the buffer. Then we need to check, was the buffer provided, right? Because in this case, our buffer may not be provided, and if that is the case, it's kind of like an easy way to write this function. The user only needs the size. So in this case, we return our size, right? Size of data that we calculated. So in other words, if the user on the first pass gives us both zeros, we calculate the size over here pretty easily, and we check, okay, 0, nothing provided, and then we return what we just calculated here, right? So then on the second pass, the user will calculate, will get the size, reserve the memory using their favorite method, and then they'll provide a pointer for us and the size of return of the reserved memory. So over here, we need to actually fill out the memory. But first, we need to compare the size provided, right? If the user gave us not enough memory, we need to actually return an error. So what we're doing, we're just checking if the size of the buffer that the user gave us is greater or equal to what we need right, over here, then we need to fill out the buffer, right? So we'll write the code here, but in case they provided, wrong buffer, in this case, well, we don't need to do anything actually. We just return this value, which will be 0. So in other words, if the user gave us not enough space, well, we can just put assert here to kind of like alert them that, hey, there's a problem. And before we do that, let's put a library here for asserts. Now, asserts is an interesting concept. I use them all the time. Now, this is not an explanation of asserts, but really quickly, this assert statement, anything inside, is evaluated, and it is used only in a debugger build. So if you change to release, all of these things will be skipped, so they will not be included. And the reason I put them is only for the debugging build. And in this case, when you get when the evaluation when it returns false inside of assert, you will get a pop-up and the execution will be broken. In other words, you can invoke the breakpoint, and this will tell you a location in the code where the error took place. In this case, I'm doing assert false, which means it will trigger all the time. And this is because of this conditional statement, which means there is an error here, and it will basically alert me to something during the debugging stage. Okay, so this is what asserts are. Okay, well, and over here we are sure that the user provided us enough buffer. So at this point, we need to fill out our buffer. And the way I personally do it, again, there are many ways to do it, but I create a byte pointer to destination from the beginning of the buffer. And the beginning of the buffer, if you remember, is pbuff that the user provided. And then I fill it out. Before we do it, though, we need to clear provided buffer. Now, why do we need to clear it? Well, this actually has been a problem in some implementations when, the buffer was not cleared. And the reason being is that by not clearing the buffer, you might be leaking information from the memory space of the app that you're sending your serialization from. And the reason you will be leaking information is that, remember, there will be gaps between variables in the binary buffer because of the alignment. So in this case, it is very important to clear it because it's not going to cost us too many CPU cycles to clear it. And we clear only the data that we will need. And this is just very simple instruction here. Okay, so at this point we can start copying the data. So, well, how do you do that? Well, obviously we need to kind of think about our alignment, right? So we did the previous template here. So yeah, we wrote these not macros, these templates to do our calculation of the alignment. So let's continue in the same fashion and kind of like try to use them. Okay, so before we actually move it into a template, let's just see how we will do it. So we have our pointer, and we need to put our data in there, right? So for instance, if we have just a simple primitive type, so we just need to do this, but before we can actually do it, we need to convert it into an int pointer, right? This kind of like old C school way of doing it. Again, there are probably other ways to do it. I personally kind of code it in a quick way. Again, programmers are lazy. We don't like to type much, so this is my way to do type conversion, typecast in C. And then we need to update this using the size of the aligned data, like so. So, and that will be one way to copy the age into our array. Now this is kind of like pretty wordy, so why don't we create a template for that? And just gonna reuse this thing. So template class will be inline, and it won't be returning anything. And let's just see, copy aligned. And in this case, actually have a variable here, and what we will need is a reference to it and type that we will be copying. Now this part is a little bit confusing because, you know, I'm using this asterisk and ampersand in one place, but what this means is that I am taking a pointer, and not a pointer but a reference. This is reference and this is the pointer. So I'm taking a reference to this guy here, and the reason I need a reference is because I will be updating it inside the template. And this parameter by value is the actual primitive value that I'm taking here that I will be adding. And what we can do is actually take all this stuff and put it inside of a template. And the only difference is that the type is T and the value is S, and this is P, and this one is S, right? So we just like rewrote all that stuff inside with the template and just write a small comment and copy primitive type into a memory location, right? So, okay, I don't need T. P is pointer to the memory location. It will be incremented by the size of S, and S is the primitive variable to copy. Okay, so now we can actually use this template into our serialization function. And again, if you remember what we're doing here, the first parameter is PD and the second parameter is age. So let's make sure that it compiles. And sure enough, we forgot to change because again, it's not PD here, it's P inside of a template. So let's do it again. Okay, so it works. And next, let's see, what do we have next? We have a string, right? So, and copying a string is a little bit more complex. So let's kind of like jot it down here in the function, and then we'll create probably a template. So with the string, if you remember, there is a size T, which is the size of the string, right? So let's just kind of like code it real quick. And so we get the size of the string. Then we need to do this kind of thing to place the size, right? So PD size T, and we are placing the size of the string, and then we're adding right. So if you remember the way we agreed, so first in memory would be the size of the string, and then the string itself as the array of characters. And again, we're just breaking it down into primitive components. Okay, so let me just separate this a little bit. So at first we get the size of our string, we place it in memory, and we update the memory to the next location. Again, we do it aligned. And the next thing that we need to do, we actually need to copy the string itself. So D is the destination, and our name, our string, so we need to get C string pointer to it. And then we need to copy the number of characters from that string, right? So CZ string in this case is the length of the string in elements. Again, remember the element means one element inside the string. In our case, one element is a char, but it could be white char. That's why we need to always multiply by the size. And in this case, remember we created this preprocessor global definition that we can do, use here. Okay, and last thing we need to do, we actually need to update a pointer not by the size of the data that we copied, but by the align size, right? Because you remember align might actually be greater than this value of how much we copied. And this technically will copy our string. But again, this is kind of like wordy because we'll have to do it many times. So why don't we put this into a separate template? And the easiest way, I'm thinking, is just to reuse one of these. As you can see, I already have this one. So let me just create another one. I'm just going to copy this one. Again, be very careful with copy and paste to make sure that you can actually modify everything. Okay, so I'll give it a new name, copy align string. So the first parameter is the same, but the second parameter is the reference. This is very important. You don't want to pass the whole string as a copy. That will be horribly inefficient. And I can probably just copy this thing as well. And copy STL string into a memory location by size of string. And this one is an STL string to copy. Okay, and it doesn't return anything. And so what we need to take this stuff and change it here. So if you remember, we don't have CZ string given name anymore. We just have S, and PD becomes just P. And again, this is important that we take our pointer by reference so that when we update it, it is updated where we're calling it from. And I think this would be our template. Let me just make sure. So yeah, so CZ string is this local variable. Okay, so now when we have this, we can actually start using this template, which will really simplify our life here. Because if you remember, we have several strings. So let me just do like so. So we have given name, we have second name, and we have third name, right? So this is kind of like the power of templates or functions in this case, but the template is good because it will actually be probably unfolded into inline code, because again, we kind of asked compiler to do it. And okay, so let's see what's next. So attendance, well, attendance is a primitive type. So we're doing it this way, right? And then we have several primitive types, I think 2 more. We have suspended. And what I'm doing, I'm following the pattern here, which is important, right? Because we calculated the size here, so we can't add or improvise or add something that we didn't announce earlier. And last thing is notes. And this should technically take all of our data. Yep, notes, performance, suspended, attendance, and names. Let's make sure. Yep. Okay. The last thing that I always do in this case is what I call a sanity check. We need to make sure that our pointer, remember we are constantly updating this PD inside of the macros. We need to make sure that our pointer is at the end of the array, or in other words, when we subtract the beginning of the array, that we are exactly at the size of our data, right? So that we didn't go over, because we obviously don't want to create buffer overflow. Now, if that is the case, we are all done. Good job. And so what we need to do is return the size of our data. Remember, like, we have to return something that is not 0. If we return 0, like it's here, it means it's an error. So in this case, we return the size of the data, everything is fine, and we go on our merry way. But if this big but is not true, it means we have an issue here. So basically we have an overflow. We technically should never get here, and the only reason we would get here if there is some kind of error in our calculations here or here, which might happen if we start adding things in the future. You know, let's say if the new developer comes in and starts, like, you know, mucking around with this code or adding new variables, and let's say forgets to calculate it here or to add it here. This is our way, kind of like internal way to tell them that, hey, there is a problem. So the first thing we do, as you saw me do before, we create an assert. Make sure we spell it right. So assertion will actually throw a debugging assertion at this spot, so the developer would immediately see, like, oops, there's a problem. But we also, if we get here during production code, our assert will not be here. So in this case, it means that there is a serious problem and we need to abort. Now, because I'm writing I'm trying to write cross-platform code, we have to do a little bit of a compiler-specific trickery here. So what I will do, I will create Microsoft specific code here, and this is a general case. In case of a general situation, I would just abort the app with the C instruction. That will just terminate the app, and that will, you know, obviously crash everything and make, you know, draw the attention of a developer. And over here, I would use Microsoft specific fast fail. And we need to see where is it defined. Now, fast fail for Microsoft, it's kind of like a quick way to raise an exception. And this is kind of like, you know, basically a way to commit suicide for the process. But in our case, this is just a way to draw attention, because obviously if we failed at this spot in our program, it means that we can't continue, right? So it means that the memory is corrupted and we just can't go on. So in this case, I suggest returning one of the let's see, fast fail. What am I missing here? Fast. Yeah, I need some include library. Hang on a second, guys. Okay, guys, I think we missed some definition here. We need to include Windows library. Okay, and so let's see if it would let us include one of those fast fail. Okay, it does, and you can kind of like pick what, you know, matches the best for you. I personally just pick this one, fatal app exit. And what happens that, again, if the memory is corrupted, because, you know, we went over or under, which would be better, but if we went over, it means we corrupted the memory in our app, so we can't really continue. The only way to go is to fail. And again, it wouldn't happen unless there is some problem in logic here, or if there is memory corruption. So again, this is kind of like safest way to continue in this case. Okay, and this should conclude our serialization for the student, right? Let's make sure it works. Before we can use, though, we need to write the same type class, I mean, same type function for our MyClass class, right? That doesn't sound right, but you got the reason, right? So the thing is that this is very, very similar. So serializes the struct by converting it into a byte array, pretty much the same thing. And we can just copy and paste from the existing code. Again, we have to determine the size and then return it. So, well, let's do it. Luckily, we already have all the macros defined, so we can use, as you can see, we have year established. So we can use our previous macro here. We can do year established. So then we need to calculate the size of the name. And if you remember, we already have the macro for that. So we do that and make sure to change name, given name into name. Okay, next is the vector. We will do it last, but then if you can see, there is a nodes variable, so let's do it here. And again, the permutation here makes it, for the addition, it means that we can do it in any order. So this will give us length of all of these variables except the students. And we have to do it a little bit different for the students because it's a vector. We need to enumerate or go through all the variables inside of it and basically calculate for every student how much space it needs. So there are many ways to do this. I personally like using iterators. So we just go to begin. I do the same thing, and let's just say this is a constant itself, and let's say iterator end, and this will be end. Okay, and then we have a for loop. Again, there are many ways to do this. There are modern ways to do it with the for loop. I personally prefer to unfold it like this because it's kind of like more visible for me what I'm doing, but again, do it whichever way you like. Okay, and then what we do, if you remember that every student had its own 2-byte array, right? So if we go there, this is the function that we just wrote. If we don't pass anything into it, it will return us the size of the bytes needed to serialize this specific student. And then that's what we're doing here. And then we just add to our size, right? And that will give us a full size. Okay, and then we kind of do similar stuff as we did here. Really don't have to type it up again. It's very simple. So let me just get the ending. Again, in this case, copy and paste would work. So let's make sure. So over here, we calculated the size, right? So size CB data is the data. Then we see if we get a pointer. If we don't have a pointer, we just return it. If we got the pointer, we make sure that the user actually provided us, enough data, enough space to fill all of our data. And if not, we assert and basically return error. And over here, we are filling up exactly as much data as we need in the memory. Because again, over here in this if statement, we are sure that user gave us an array that is long enough. And yeah, so now let's just kind of like do what we did here. So first we need to copy year established, which is just a simple type. Then we have the name, and we can use our previously copy aligned string. Right, so, and we have our name. Now then, we have to remember, again, we don't have to specifically follow it, but, let's just kind of follow the structure or the order, how these variables are present in the class. So next we need to copy students. And let's just say students array. And in this case, we actually need one extra variable that I forgot, because the array, if you remember, like, or list or whatever you call it, vector in STL, it actually contains number of elements, right, that we need to encode, followed by the students themselves. So it will be, we need to figure out how we will encode these students in memory. So if you remember what we did with our string, we specified the length first, and then we specified the array of characters. In this case, what I'm suggesting we do, just quickly draw a diagram. So size t will be count of students, and then we go with the array of serialized students that follow. So this way, the count of students will tell us how many elements are present in this array, and then we will go element by element afterwards. Okay, so again, so what we're missing in our definition, in our calculation here, is that we didn't specify the count of students. So, well, let's do it here. So I would say that we also need this, but calculated for the size t. And let's make a little note here. So we are specifying, let's just say count of elements in the students array, right? So this will contain how many elements we need. And when we place those elements, we need to first get the size. Let me just put it into separate local variable, and let's just say students and size, right? So then we do copy aligned, so we put all of us, the number of students first, increment our pointer, and then we just copy them, right, in the for loop. In this case, we have an iterator already, except that we need to initialize the beginning. And we need to make sure that pretty much we're not at the end, and we increment. We kind of do the same as we did over here, except that again we need to initialize the ITR because we kind of like updated it here. So we initialize it to the beginning and then go all the way till the end. And so over here, let's just create variable. So if you remember, when we call to our byte array, so over here we need to provide the pointer to our memory, which is PD, like we have over here, so we continue using it. And then we need to specify the size of the buffer available. Now, if you remember, we need to have the end of the, we need to basically calculate how much data that we have available. So now if you picture, let me just kind of draw it real quick, right? So if you picture like continuous memory, so if we like, let's say if PD, our our pointer D is at this location, so the element that we have is probably going to take this much space, but our toByteArray that we wrote for the students, we need to specify the full available length of the buffer. And if you remember, if we go over, you see like greater or equal than the size needed, this is not a problem. It will fill out as much as it takes, and then will return us the size of the needed data for that specific element. So in other words, so what we need to specify here is the full size of available of the array that is left. And how do we do that? Well, we need to have the ending of our array. And we can create another variable here and just calculate it pretty easily as the size of the data plus the beginning, right? So over here, PD is the beginning of the array, and then size of data is our calculated full size of the full array. So over here, when we know the ending, we can just say pend minus pd. So that will literally take us the space available from the current location of the PD over here till the end of the array. And then we pass it into the function for the student. And then the student returns us the size of the data used. In this case, though, we have to be aware of the error condition. As you can see, it can return error if something went wrong. So we need to check if we failed. In this case, we are facing with the same result as we did here. If we failed, this is most certainly an overflow, so we need to kind of act in a similar manner. In other words, let's just say failed. And in this case, we assert in the debugging build, but then for Microsoft specific compiler, we do fast fail. In other words, crash the app because something went horribly wrong. Because again, we should not be failing here, because if you remember, we already calculated the needed size. It means if we get into this statement here, into this if statement, it means that our function that calculates the size of the students is off or incorrect. So in other words, this is a way for the developers to realize that, hey, there's a problem. But most importantly for us, if we got the non-zero size, it means that we have to step forward by this number of bytes and continue on, right? So this is the size, and we increment it, and we go to the next element. And at this point, so when we go through the full array, so next time PD will be updated, so, and we continue on. The only thing I would do here is that I would actually add a line, because yeah, although, you know, hold on guys, if we go into our, no, we don't have to add a line, because we've been using align statements here, so scratch that. We are guaranteed that our return value will be aligned, so we don't need to do it. But the only thing we need to do is to update our pointer to the next student. And then if we go through the whole array, if you remember at the end, we have this lonely nodes that we also need to add at the end. And that is a string. So we add it here. The only thing we need to remember, we actually need to change the variable name. Again, this is the common thing. It's just not at the end. Okay, it's a common thing when people copy and paste and then forget to change the variable. Okay, and if you remember, I have to do the same sanity check as I did before. This is important to do. And this is exactly the same thing. So PD minus the beginning has to be the size of the data. If so, we return the size. Otherwise, we crash the app, because this is some kind of internal problem. Okay, let's make sure it builds, and it does. Okay, well, this, I think, will conclude our serialization code. And one very important thing is to test serialization. So, well, since we have pretty much everything written, so let's just do, if you remember, our function here returns the size, and for us in this case we need to make sure that this is not 0. And okay, so first, if you remember, the way you call it is that we need to pass all zeros by ignoring all the parameters, and internally it will pass zeros. So this one will give us the size of the needed buffer. Let's make sure that this is not 0. And If it is 0, we assert, meaning that, hey, there's a problem. Okay, then we need to allocate the memory. Now, guys, there are many ways to allocate it, and recently people were really bashing the new operator. I personally have nothing against new operator, so I'm going to use it here. And if you are not safe with pretty much any tool, you should probably not be using it. Obviously, when you use new, you have to remember to free the memory. So again, this is not that difficult to do. Right, and I usually clear the pointer so that we don't start using it. So again, it's up to you how you allocate memory. You can use your vector or whatever class you like. So over here we allocated enough memory, and then what we need to do, we need to actually call our class again and call toByteArray, but in this case we need to pass it a memory and a size, and if you remember, on the return it should return us the exact same size as we passed into it. If it doesn't, we have a problem, and if it does, it means that we have serialized our class, right? So, well, in this case, let's just do a simple cout, and let's say serialized, okay, length of data, and let's just say how much data, just output how much data we produced. Okay, and that will technically do the job. So let's build it and let's see if it works. Okay, and again I put a breakpoint here on the serialization logic. So if we step into it, just move this out of the way. Okay, so first, as you can see, both parameters are null. So we calculate the size, and as you can see, we need 80 bytes. And is it hex? Nope, it's 80 bytes decimal for main logic, and then we calculate all the students. So let me just run to cursor. Okay, so we updated to 576 bytes, and in this case we step over, return, we reserve the memory, and let's just put it over here so we can see. So over here will be our memory. Right now, as you can see, it has its empty, has debugging variables. Okay, and on the next step we should technically fill out the memory, and we did. So as you can see, first parameter, if you remember, was the year established. It's 07 E7. It's basically a hex number. So 7E7, it's 2023 in decimal. And as you can see, the variables are aligned on 8 bytes. Because remember, what we did here in the beginning, we wanted to align by the size of a pointer, and because we are actually compiling for 64-bit, this is 8 bytes. So the next parameter here is the size of the string, right? And it's also aligned on 8 bytes, and then we get the size of the string that goes here, and at the end we pad to the next alignment, and we keep going. So again, there are different things, I don't remember them now, but right now if you see here, we actually have these strings encoded into our binary memory. So okay, and at this point we can just output that we serialized okay. The length is 576 bytes. And so this tells me that the serialization logic is working. So let me just add a little bit of improvement here, just to make sure that our app is not, closing. So yeah, so it's working. 576 to serialize our 576 bytes to serialize our array. And just to show you that we can actually control this pretty easily, if we, let's say, comment out this line and build, this technically should not use any alignment, and if we run, you see the size is 447, so this is way less. Now, the alignment will depend on your CPU. For instance, in case of Intel, it doesn't really need alignment. It will make it less efficient, but it still works. But in case of, let's say, ARM, especially the latest 64-bit ones, you definitely need an alignment. And let's see what happens with the memory layout. So if I do again pmem, copy it into memory view, and run the code, as you can see, the first variable year is taking 4 bytes, and then the following one starts from this offset. You see, like, this is the size of the string, and again, we used size t, and it's 8 bytes. So now the string itself starts on, kind of like this offset. So everything is more condensed, but again, if the CPU needs alignment, this obviously wouldn't work. So, okay, and I think, let me return this back. And obviously you can specify any arbitrary alignment. So if you want to align on 2 bytes, right, you can do it this way. And again, if you run, just to show real quick, so if we go into memory, everything is aligned on 2 bytes. Again, this is not that much different, but you are not limited to, size of. You can actually set, I don't know, 16, for instance, right? So when you do this thing, it will be more spaced out. And let me show you. So memory in this case, you see, like, there are big gaps. So for instance, this one is aligned on 16 bytes, and this one is aligned on 16 bytes, and so forth. So again, it all depends on the actual requirements. So let me undo this real quick. So I personally would leave it with the alignment to the pointer, because again, this makes it more efficient, even though you are wasting some space in the serialized data itself. Okay, guys, and one last thing that I wanted to look at is the efficiency of our alignment itself. Now, if you look at this part here, this is not very efficient, and I'm kind of curious if the compiler was smart enough to kind of like improve this part a little bit. As you can see, we have this, modulus operator in 2 places. Then we have a conditional statement. So if it's doing this kind of thing internally, that will make it very, very slow and not really nice. Now, there is a way to kind of optimize it a little bit. So let's kind of see as a side project what happens internally. And for that, I need to build it as an optimized release build. Let me build it. Okay, so let me locate it. I usually do containing folder, and it's an x64 release. Let me run it. Okay, so it works. And let me move it into my debugging environment. Now, how to set up this VM is a separate subject. I will post a link in the description where you can see how I set it up. But basically, we'll need either free or any kind of user mode debugger. So in this case, I will use IDA. So let me copy this thing over here. And by the way, let me take symbols as well, so it's a little bit easier for us to analyze it. Okay, so let me make sure it runs. Okay, it does. And let's open it in IDA. Okay, now watch my separate tutorial on how to do all this stuff, but basically it's just a very simple binary review. Okay, so we're in the main. So what we need to do, we need to locate our logic that starts from here. And you know what? I didn't do one thing. Now, because of all this stuff, we will get a lot of code to fill out this array. usually what I'm doing, I'm inserting a API. Like in this case, I picked this one because it starts with A and it's pretty easy to locate it. It's one on the top. And if you pass 2 zeros into it, it really won't do anything. And the reason I put this API for my tests is that I can kind of skip quickly through all this stuff in the assembly language and just locate this instruction here. So I can kind of like find it quickly. So let's rebuild it. And let's go back and need to close item. And yeah, sorry guys, I should have thought about this. So need to delete. And then we need to take new build and move it into the VM and kind of like do the same thing. But in this case, we will use our API here to locate the beginning of the code of interest. It's almost like putting a marker. Obviously, I will not use it in the production code because I'll edit it out. It's just something for me to find in my test build. Okay, so right here, if you see, we're in the main function. And over here, there's a lot of code, which is not very readable. And what all this thing does, it's basically populating this stuff, because again, there's a lot of stuff going on here from the C++ perspective. And if we scroll all the way down, what we're looking for is my special marker, this activate act CTX. So if you can't find it manually like this, which I did here, but you can put a breakpoint on it, and it's in kernel 32, and run the app, and it will break on this specific location. But in our case, we're kind of lucky. So, and over here, we have our call to my class. So let's put breakpoint and run our app. Okay, well, IDA is asking things, but okay, so we broke on this location. Let's go into graph view and step into it. Okay, and we are inside of our function. Yep, so as you can see, my class toByteArray. And let's quickly step through it and see how, again, what we're looking for is how efficient our alignment function here. So let's locate it now. Now the easiest way to locate it is probably in this loop, right, when we add students, or maybe if we do it here. So let's just see how compiler did it. I see that it's doing some calculation here, and this logic over here is probably, yep, oh boy, yeah, that's a long one. Okay, well, let's get to it and see what happens. Again, I'm kind of quickly stepping through all this stuff. Okay, so I believe all of these things are lengths of strings in our student. Let me see how many strings do we have here. We have 1, 2, 3, 4. Yeah, so you see, like, it does all of these things. Basically what the compiler did, it unfolded calls to our toByteArray into kind of like inlined it basically, and it's in this loop here. And yeah, it seems like it was doing it, optimized it a little bit. But you see, like, this C move Z, it's basically conditional moves. Like if something is not 0, it moves this into this, and yeah, this is not very efficient. So at least it didn't use jumps, but it used a lot of these, you know, a lot of these checks, because you see it's testing. And yeah, testing again. I don't want to review this whole logic here, but yeah, I think it did somewhat okay job, but let's see if we can optimize it. So guys, let's try to memorize this chunk, this loop, which is, yeah, it's not super small, but yeah. And let's try to kind of optimize it a little bit. So let me close item, and I don't want to save anything. Delete these for now. Let's see how we can maybe rewrite this thing. Now, obviously, the way you would align by is that this alignment would be a power of 2, right? So you wouldn't be aligning by, let's say, 7 bytes, right? It makes no sense because, you know, most CPUs require alignment on by 8, 4, 16, and so forth. So in other words, this value won't be like some weird like 13, right? So obviously nobody would want to do it. So, and if we are dealing with a power of 2, we can rewrite this, right? So we can use logical operators instead. And what we can do is that we can do n plus, right? Because we need to add something. Then we need to see, we need to take the minus of n, and what I'm doing, I'm kind of using a logical operator here, and we take minus of n, we basically invert all the bits, because 0 in case of minus 0 will stay 0, so we won't get anything. But let's say if we have 1, right? So let me just explain what I'm doing here. So 0, if we invert it, it becomes 0. 1 inverted becomes minus 1. But then in a binary form, it becomes all f's, right? And 0 becomes not 9s, but all 0s, right? So, and then, so if we do an AND, and with alignment minus 1, let's say 8 minus 1, right? So we end with 7. So that would give us the result. So in other words, if we have 1, we end with 7, it gives us 7, right? If we have 2, minus 2 becomes FFE, and then we end with 7, that gives us 6, right? So, well, just to show you what I mean. So if we go take our trusty calculator, right, and then we AND with 7, that gives us 6. And if we AND 0 with 7, that obviously gives us 0. So this way, by doing this AND with alignment minus 1, we can technically avoid all these conditional statements and modulos. So if we do this with our align by minus end, again, this is kind of like not really readable, but we take our n, we negate it, and before we negate it, by the way, we need to make sure this is a signed value, because, you know, if n is unsigned, the compiler will complain. So in this part, we negate our value n that we passed, and then we end it with align by minus 1. So if align by is 7, is 8, we get 7, and we end with 7, and we get the value that we need to add to our n. Okay, guys, kind of confusing. Again, review this bitwise logic, and you'll know what I'm talking about here. But before we do this, we need to do a couple static asserts. And static asserts are the ones that happen during compile time. Well, first we need to make sure that our align by is actually greater than 0, right? Otherwise it will be ridiculous if we set this to 0 or negative. And let's, as an error, we say alignment must be positive. And the second thing that we need to check is that aligned by is actually a power of 2. Now there is many ways to do it, and I will use the new pop count STL function, or is it part of the STL, I guess? And so what we're doing, the pop count will calculate number of bits or set bits in our align by, and if it's 1 bit, it means it's a power of 2. And then we need to specify, if not, we need to say that alignment must be done by a size the power of 2, not 12 but 2. Okay, so this way at compile time we will check if our alignment is set correctly, and let's make sure that this compiles. Let's see, pop count is not interesting. Oh, okay, now pop count is the feature of C++20, so we need to change that, and let's make sure that it likes it now. Okay, and also need to do the same for the debugging build. Again, guys, the pop count is something that was added in the C++20 standard, so in case you can't use C++20, make sure that you write your own function basically to do that. So I'm kind of lazy, and I'll reuse what STL provides, and this should technically give us the result. And so what we're doing here with these two static asserts is that we check at the build time, at the compile time, that our aligned by is set correctly. So right now, if we run it, right, everything works, so pretty much nothing changed. But if for some stupid reason we decide to put like 13 over here, right, so when we build, it will create over here, right? So basically it says like, hey, sorry, you can't, well, in this case, yeah, it can't even work. But basically what this has to be is something that is divisible, that is a power of 2, right? So let's say this, or if you go like really short, all of this stuff should work, but otherwise the static assert or pop count in this case will not work, and you will get a build error. Okay, so let's make sure that this runs. Okay, it does. And let's build a release build and test it with the IDA to see, how the binary itself looks. So let's make sure that the timestamp is correct, and it is. And let's move it into our debugging VM. Let's open it in IDA. Again, the process is very similar. We just want to see how that loop looks like. And I think we didn't save it, so the breakpoint went away. So I have to scroll down all of this monstrosity, and that's again setting up the array for us in C++. And over here, oh, we commented out our special beacon here, but that's okay. We know where we are. Okay, so if we put a breakpoint here and run this thing, okay, we don't really care about that one. Let's see, step in, and let's just go through real quick to see how our loop looks like this time. And I need to go into graph view to make it more readable. And sure enough, you see, like, I'm sure you remember the loop before, and you see how much smaller it is. So it just tells us that the compiler in this case was not really smart to kind of like convert this into this one. Maybe I shouldn't be the stuff on it, because obviously it didn't have this assumption that we will be feeding it only, the aligned by, which is the power of 2. So in this case, human interaction would be important to optimize it to this kind of form. And again, as you can see, this loop is way more manageable. It doesn't have those conditional move instructions. It just basically does this quick calculation here, which is way more streamlined and way more performant. Okay, well guys, at this point, I think that will cover it for the serialization part. Again, this video kind of turned out pretty long, so I'll cut it up into pieces and I'll put time codes into it. But this will be the first part that describes serialization, and please come back in the second part where we will talk about de-serialization and where secure programming practices will actually come into play. So thank you for watching and see you next time.